All right, let's see. I think we have sound today. What's up, everyone? Hold on. Everything is not working right now, but I think sound is working. Let me know if you hear sound. Something's wrong with my camera. I don't know why it's doing what it's doing. This latest Windows update has caused all kinds of problems, and so I was just trying to work out some of those issues just now. But things happen. Things are happening with the computer. It's being super odd over the past few days. Really bothering me a lot, actually. So let me deactivate and let me reactivate and see if it fixes at least my camera frame rate. All right, we're not gonna worry about it. You're not here to see me. We're here to learn some Docker. At least the frame rate for the actual screen capture is all fine, but welcome to Mastermind Academy. Welcome to Contained. Glad to have you. Tonight we're going to be talking about building Dockerfiles. We're going to learn how to actually write Dockerfiles ourselves. We're going to learn how to manage images as well. So it should be pretty fun. And I think we're going to hop into it pretty early. You know, I just got done eating. I'm going to eat one more chip because I'm still hungry a little bit. Sorry about all the chewing in the microphone, but we'll give people just a few minutes to hop in, and we're going to hop straight into it because I think tonight, I think it'll take up all the time. Just because we'll be messing around, building different things, and yeah. So 2 things I want you to do if you want to follow along tonight. Hit !contained. Tonight, if you want to follow along, you're gonna need, if you don't, hopefully you have Docker installed already. But you'll also need a text editor of some kind. I recommend Visual Studio Code. Inside of the Notion is a link to VS Code. I would install that one, and I'm probably not gonna, I might use it just to show you where the plugin is. But we're gonna build some stuff tonight, and I'm gonna actually build it in Windows since I do have WSL2 here now. I will be actually building this, and it's in Linux, but it's gonna be in Windows. What's up, Fairybot? She boss. The energy every time you're the best. You're the greatest. First off, you need VIP. You definitely need VIP. The she boss. Thank you so much. You are now a VIP of this channel. Wouldn't have it any other way. But what's up, bevy of codes? What's up, Angry Rican? How are you doing today? Sharky, what's good, bro? Afro9, how are you doing tonight? Introspective Samurai, the best names. I love it. M Doubles, good to have you. Frequency Hop, X3M Linux, good to have you as well. And again, Fairybot, how you doing? Just moving all this stuff. Got I have my bottle of water, but it is out of water. It's got a little bit of ice, a little bit of water there on the bottom, but I'm working with the Deer Park. I try to stay away from reusable plastic bottles, but you get what you get. You get what you get sometimes. Oh no, the She Boss, absolutely. You've been a big supporter, so wouldn't have it any other way, like I said. But yeah, tonight is images and building containers, and I think it's gonna be pretty fun. So if you've never written any type of code, this is gonna be fun because it's gonna make you feel like you're writing code. I don't necessarily consider it code. Personally, it's more like configuration, but it is a pretty cool thing to do. You're now going to have some things you can play with, some tangible files that you can kind of use and mess around with, and it'll be fun. So we've been learning about the basics. We've learned about, how to actually run a container and things like that. But none of that, all that's great. But, if you don't know of a container that you want to run or an image that you would like to run, you probably haven't been able to really just mess around and play around yet. I think what tonight will give you is a leg to stand on so that you can start playing around and messing around and seeing what you can make happen. So we're going to hop straight into the slides right here. And let's present this. And let me move this over. Let me make sure I can see what's happening on stream really quick. I really need to figure out what's going on with my computer though. So my computer is pretty powerful. It's a pretty powerful computer. I don't know that I could make it much more powerful than it is with consumer grade stuff. I can move up to Threadripper stuff, or I can move up to professional level graphics cards, quadro lines, but it's been acting super weird lately with both games and with anything else that I want to do. I might have too many inputs or something. I have a lot of stuff plugged in, but I have 64 gigs of RAM. Don't need it, but I have 64 gigs of RAM. I've got a 16 core CPU, 32 threads. I have 2 really fast SSDs in here, but you can throw all the hardware you want at it. If the software sucks, then it will be problematic. We'll see. I'll troubleshoot. I'm sure something that I'm doing. I'm sure something that I'm doing. Not sure if this is the case. Mine acted the same way. It was temperature. It could be temperature. Let's actually check that real fast. Well, let me check the temperature of at least the what are those things called? Of the CPU and of the GPU. GPU temps really good. Pretty sure that's pretty good. Pretty sure that's nice and cool. And the CPU temps looks good, 50 degrees, mid 50s, seems pretty good, but all good. I'll actually keep this open to the side and see if it gets any better a little bit later. But let's go ahead and dive in so we can actually build some stuff so I don't take up all of your time tonight. But here are today's topics. Persisting data. We talked about this a little bit last time, but we're going to dive deeper into persisting data today. This is one of the most important things to learn when kind of understanding how containers work, is how to properly persist data. It's pretty simple, but it's good to know about. We're gonna learn about some image management. Last time we learned about container management, so we learned how to again start and stop and create containers and how to remove them to clean them up and the way that we can see them and know what's going on. We will do the same thing tonight with image management, which is a little bit simpler. Then we'll do, I don't even know how I put intro to Dockerfiles. You're gonna learn probably 75 to 90% of what there is to know about Dockerfiles. So maybe it's a little more than an intro. And then we're gonna understand layers, and then we're just gonna build. We're gonna practice building some things as well. And when we do that, this part at the end is like a catch-all for what we're going to be doing throughout the night. We're not going to wait till the end to start building stuff. We're actually going to start building stuff pretty soon, probably right when we get into Dockerfiles. So hold on to your butts. So let's go. Persisting data is what we're going to talk about first. So the data problem. Containers are designed to be ephemeral and isolated from the host machine. This creates problems when data is involved. We all know that data is a very important thing. All of the big companies out there are collecting, even small companies are collecting our data right now to be used against us for advertisements, for whatever. They say it's for our benefit, who knows? But data is very important. Data is also very finicky. But data needs to be saved. Data needs to be held somewhere permanently. Or for long periods of time, and because these containers are ephemeral and isolated from the host machine, we need to worry about this data. So we talked about this one last time, I think, but solution one is the mapping of volumes. And so for a while this was the option, but like we do with ports, just as we did with ports where we mapped, we exposed the port in a container and mapped it to a port on the host machine so that we could access it on the host machine. Same one thing we do with ports, we can map a container directory. So we can map a folder inside of the container to a folder that is on our host machine. So we can connect, again, a folder that's in the container to a folder on the host machine. So there's this little bridge there. So anything saved in either folder will be available in the other folder. And so, it's this little link now. So it removes a piece of isolation. Now there's a way into the container, but this is the number one. This is the first solution that came about for this. This will allow data saved in the specified directory in the container to remain in that directory when the host machine on the host machine when the container is removed. So let's say a container does this job, it finishes up and it dies. If we go ahead now and we remove that container, as long as you have a volume mapped to your host machine, that data will remain in that folder on the host machine. It'll basically get stuck there, and you can retrieve it at any given time. It is now persisted to your host machine's hard drive, and it's a pretty simple thing to do. And so let's actually show you what that looks like really quick. Let's learn about the other option as well, and we can do them both together really quickly. The other one is Docker volumes, and this one's gonna introduce a few more commands that you're gonna have to learn, but this is the preferred method now. It's the preferred way to persist data. It is a newer method for sure, a solution that's fully integrated into Docker. But these are volume mounts that are managed by Docker. It's actually not all that different. It's not all that different from the other option in actuality, but there's some great backend management and stuff that happens. So there's a link here that I will share, but let's hop in. Actually, let's share it first in the chat. Copy link address. Let's share it if you want to head over there to give you information about volumes, but we're not going to be looking at that right now. I just wanted you to have it. What we're going to be doing is looking at these two solutions real time really quick. And so I haven't done much with Docker on Windows. So I'm running WSL2 finally. Just got WSL2 installed this weekend, which allows for Docker integration, native Windows Docker desktop integration, which is super nice. So I can simply run a Docker PS right here, and look at that. All that stuff's running great. I'm running it in Windows Subsystem for Linux 2, and everything seems to be working fine so far. If we run into any oddities, I'll note those because they will be very confusing to me. So what we want to do first is I don't think I pulled Ubuntu on here, so I'm gonna pull Ubuntu really fast so that we have, I wanna use this really quick, but we wanna talk about persisting data to the container. And so what I'm gonna do is I'm going to run a container. I'm running the first option. So I'm gonna run an Ubuntu container like we did last time. And I'm gonna map it to a directory here. I'm actually gonna create a directory. Let me move into a new, whoa, no, what happened here? What is ESH doing? I see it in the back quote, CD oh, that's weird. I've actually never seen that before. Backtick. All right, there we go. CD documents, let's CD into mastermind, and let's go ahead and make a directory here called Docker. Let's call it Docker, let's call it contained. All right, so we have this directory here, and I'm gonna make a new directory here for us to test from, and I'm gonna call it test_dir. And now there's just a test directory here, and in there's nothing in this test directory that I just made, not a thing in there, but I'm gonna put something in there right now. So I'm going to go in here and I'm gonna vim a file called aaron.txt, and in here I'm just gonna put in my name is Aaron. So now there's a text file. This text file in this directory called my name is Aaron, and that's all that's here. Nothing else here. Cool. I'm gonna go back. So if we want to map a directory, I'm going to attempt to map this test directory to some type of directory inside of the container. And so here's what we can do. We can put our run command together. So Docker run, and I'm gonna say -itd, and I'm gonna say Ubuntu. Wait, actually I need another flag. The flag for this is a -v. -v is the flag to do volume mappings, and I believe I never remember, but I believe it's going to be the container directory first. So I'm gonna say @/mount/test, go ahead and mount /testdir. Test is that, I think that's what I called it. I think I called it test_dir, and then the name of the image that I want. So -v is going to say, hey, go ahead and map a volume in the container that's about to start to a volume to a directory that's here on the host machine. I might have the order of these flipped. I'll fix it if not. I always forget syntax, no big deal, because also, like I said, As you get farther into your Docker usage, you probably won't be running raw containers like this. So we'll, you forget that syntax, but I'm going to run this as is. And actually, let me start it with let's run it as is. Okay. And we get some output, which is nice. That looks like a really long container ID to us. And let's go back and let's figure out how we can do, how do we know if this is running? Remember our commands to check if a container is running, and we do docker ps, and great, we do in fact have a container running. And what I'm gonna do is I'm gonna run a docker exec -it for e. So I'm gonna grab the container ID /bin/bash. And so you can use either the name. I could have typed in cool more right here, or I could have put this whole container ID here. But again, remember I said you only need to put in enough to make it unique. There's no other containers running, so just 4 would have done it, but I just did 4e. And let's go in, and I can now change into /mount. All right, and in here there's nothing, so my mount command is wrong. Do you need an absolute path tester? You do not need an absolute path. You don't need an absolute path, but make sure you can use an absolute path, absolutely. But again, you need to use whichever path works properly. And so I don't remember which one is which here. And so let's actually look it up really quick. Docker volume mapping. I don't want to use volumes. Yeah, I want to use the old school stuff. -v data. Now this looks like volumes as well. We can look in the Docker run help. Oops. Docker run help. Whoa, not Docker run dash help -v volume list mount bind of volume. I wonder if this has changed, because this looks like it's specifically talking about new volume drivers. I need to change the volume driver. Let's see, give me 1 second. Let's try this again. What was the run command I had? Test. Let's try to flip it really quick. Let's just make sure the name of the file, it is testdir. Let's try to flip it really quick and see if that works. So stir into /mount /testdir, and let's try that. And now that opened up a second one, and I probably should have killed the first one, but all good. And I will log into this new one. And all right, so this one worked. So I'm gonna go into /mount. So it is which one's first? Darn it. I'll call them the same, but it is the local directory you want to connect to. That one is first, and then colon, and then the directory that you want it to map to inside of the container. So now I have this test directory here. You do not need to call them the same name. I could have called this a different name, but if I go into /mount /test directory, notice here I'm inside of the container. I am not getting this prompt, which will let you know I'm on the host machine. I'm in the container. This is the container ID right here. See, it matches this container ID. And now there's this /mount /test directory. And in here, oh wow, there should be a file. So maybe actually, oh, okay, I know what happened. I had it right the first time. I think I had it right the first time. The reason why it didn't work first time is that I put this / here. I think so. What it did here is it created this test directory because of the way that I mounted this, but it is not actually mapping to anything proper, because I do the same thing, because I did the same / here. And so let me fix this. This might be this also might be the right thing. And so this is why file pathing is so important. If you are watching Waddle, this is why file pathing is so important. I put a / in front of the test directory here and here. And what does that mean? That means that it is starting to look for test directory from the root of the file system rather than this actual location. So that's a big mistake. I think that goes to your question, frequency hop. I didn't realize what you were saying. I was going too fast. And no, you do not need an absolute path here. And my Fitbit thinks that I hit 10,000 steps just now. So good way to trick it. So I'm gonna stop. Let's just create another one really quick, a brand new one, and let's run, and let's do it this way. And exec into 8B, and I'll go back into mount, mount tester. What did I just run? I need to do it. Maybe I need to do a dot slash. I don't know why my file's not there. It should show me a file here. I'm back out again. Let's try it one more time. Let's try dot slash test directory. Error response. That slash test directory includes invalid characters for local. It worked for me. I used the command, so it worked. The file's not there, but let's see if it works. Let me see if it works the other way. It could be a permissions issue with specifically the way that this works. But let's log back into the container that we just logged into. And let's try something really quick. Let's go back into mount. So it is in fact creating a mount here. And I'm gonna try to touch a file called test.txt. And then, yes, SimCity, I think you called it. I think I should use the Ubuntu home directory. That makes perfect sense. This is the thing that I do think the thing we're running into is some permissions issue between the Windows file system and the Linux file system. That's probably why I should have just hopped into my Ubuntu VM, but I do think you're right, SimCity. So let's actually do that really quick. Let's actually go back to here. Let's make a directory. Whoops. All right, let's make a directory here called contained. All right, and cd into contained. And we'll do the same thing. So we're gonna make another directory here called testdir. All right, so we made a directory called testdir. So we're restarting. We're actually restarting right now because of those issues. I do think you're right, SimCity. I'm gonna kill these containers really quick. Docker stop. $sign PS. Docker yes. And we can leave those stopped. Okay. So now I think this might work again. So I'm just gonna run the very last run command that I ran, which is this one, and I'll just leave it at testdir. And cool. So here's what I'll do. There's nothing in this test directory. If I go into test directory, there's nothing here. But what I'm gonna do now is I'm gonna make that file again. I'm gonna call it aaron.txt. And I'm gonna say, hey, my name is Aaron. And I'm gonna save this. All right, so we have this file inside of here, and let's look at a container. Our container is running. How do you get into it? We'll exec into it. F8, and now if I go to mount, and then in mount, we can see test directory is here. And inside of testdir is now this test.txt file. And if I cat it, interesting, there's nothing in here, but it sees the file, which is really weird. This is pretty odd. This might be an issue again with the Windows subsystem for Linux and the way that that's being used, but you can see this file here. Let's see what happens if I create a new file here. So I'm in the container right now. I'm actually in the container. I have two volumes mapped to each other. This /mount test directory, I run a pwd. This is where I currently am in the container. This is mapped to a folder on the host system. And so what I'm gonna try to do here is I'm gonna touch a file called brooks.txt. And I'm gonna make a file here. And what we can do is I'm gonna open up another tab here. And I'm gonna go into that folder. And inside a tester should now be another file that's not, oh, hold on. Actually, the test.txt file that's here is the one that we put in the other location, isn't it? I'm actually really confused on what's happening. So we have test.txt and Brooks. Where's this file at? That is not here, is it? Huh. Yeah, the new one you made is Aaron. So this is very interesting. This is very interesting. Very, very interesting. All right, here's what we're gonna do. We're going into the VM because I do think this is a file system problem. What's the VM called? VirtualBox. I think, where did I make a test.txt at? Does anyone, did I do that? Like if I do this and I go into documents, contained, but the one that's right here is also Aaron.txt. Very interesting. I don't know. I actually don't know what's happening at all right now. But what you need to know from that is simply that you can map a local directory to one in the container. I'm not sure why it's not showing me the right thing, but just so that we're not running into, just to ensure that we're not running into any WSL2 issues, because it is a new thing, and the new version of Docker for Windows is a new thing. Let's make sure we get into actual full-on Linux to make sure we can, you know, to remove any of the extra variables, which are pretty annoying. I had to go into CD tester and the root of the container. Yeah, because that's where he put it. And so his command is the same as mine. You did it home. It's the same. It's the exact same command, but I will try that. Really odd. So I'm gonna run another one just like this. Oh, whoops. I forgot to copy the Docker. Let's see. And you did it to you did it to home. So I'm in the home directory right now. So in my directory, there should also be one that is contained. Oh, you might have, okay. So I might need to create that because this is the, and you mounted it just to test dir. Oh, okay. So this is the, yeah. So there's not gonna be anything in here for me right now. It's not gonna be anything in here for me right now because I don't have that contained directory. I'm actually surprised the command worked. So I'll redo that command, which is the same command that I have. And he did the full path. So maybe I'll do the full path as well. And I'll do the full path to here, EWD, because maybe that is the problem. Tilde contained tester, all caps. All right, let's try this one. And this one is going to have a tester right here, and that's going to have it. It seems weird, so I guess I must give it the I must give it a full path. So yeah, missing the tilde contained, but so maybe you have to give it a full path here. You don't normally need to give it the full path, which is very interesting. Very interesting. It's completely fine. But so I do have Aaron.txt here, and now I'm in the container. If I do, let's test this. Let's do a touch Brooks.txt. I'm not gonna put anything in it. What I'm gonna do is I'm gonna go back over here. Dash contained And inside of this test directory, so just to be clear, right here, this is my host machine, and you can tell by the cool, pretty prompt. But right here, this is the container that it's in. So now I created a file called brooks.txt in the container. And now if I do an LL, it should show up here, and it does in fact show up on my host system. So it's right here on the host system. Now, if I kill this container and I remove it, so I killed the containers and I removed all of them. So there's no more containers on the system at all. None at all. But if I go back over here, these files still are here. They still persist. They're still good to go. So we will use full file paths for the rest of today, because that was really weird. But yeah, these files are still here and I can edit them or whatever. If I were to start up a new container, that same command, I run this again and a new one starts, and I do, let's use a new command really quick, and I do a docker exec. And I don't think I need an IT here. And I do D2, I'll just do D2. And instead of logging into it, I'm just gonna do an ls-la on /tester. So this is going to run an ls command inside of that container for us. And when I do it, it spits out these files, which are these files here. So again, you map those things up. It just creates a bridge between two of the folders. And if you save stuff in one, it'll be available on the host machine. So yeah, so you can go ahead and do that. Now, the other thing that we can do is Docker volumes. And so Docker volumes is its own managed tool inside of Docker itself. And so if you do Docker volume, you're going to get some options on things you can do. So what you can do is you can create a volume, you can inspect the volume, you can list your volumes, you can prune volumes, and you can remove volumes. And so what this does is this creates a storage device as far as Docker is concerned, and it's just a good way for you to kind of manage your data and to be able to mess with this volume accordingly, to kind of keep the volume inside of the Docker paradigm, rather than like worrying about a folder or something like that. It does provide a number of benefits. There's some interesting things for backups and things like that. It ultimately just saves this data to a file, to a directory somewhere on the computer, and you can see where that is using the inspect. But so let's do this first. Let's do a Docker volume ls to show you that oh, that's what it did. I must have did a typo, because I think it created a volume for us. Okay, this is the -v command. Okay, so I must have created one for us, but you can create one like this. You can do Docker volume create, and we're gonna call this contained volume _volume. And so what this does, if we do a Docker volume ls again, what this does is this again gives us a space. It gives us a kind of a shared space to do things and to save things to, that we can connect multiple containers to. Mapping directly to a directory on the machine also works as well. But this is the paradigm within Docker, and it does provide some cool benefits. And so to use that contained volume, I think that all I would have to do for that is to simply I think all I got to do is this contained. Pretty sure all I have to do is specify it like this. We'll find out very shortly. And so Docker exec and if I go into /tester, there should be nothing here, which makes sense. Why? Because this is a brand new volume. There's nothing on it. And so if I simply, put some stuff here, touch1.txt, touch2.txt, and touch yes.txt. I've got 3 files here. Great. And I can leave out of this and I can delete it and everything. This volume will still stay around permanently. It is just like a directory in that sense, but again, it is managed inside of Docker. But what I can do also is I can inspect this or get some information about it using the inspect command, and I can say Docker inspect, Docker volume inspect, and the name of the volume that I want to do, which is contained volume. And it gives me some information in JSON format. Again, let's get some colors in there. It says, hey, this is when this volume was created. There are a number of different storage drivers. You don't need to know about those right now. Local just means that it is saved locally here to this computer. And this is the mount point. This is the mount point right here. Varlib Docker volumes contain. So this is the actual local directory. So I'm pretty sure this is the local directory. I do this and I do an ls on this directory here. Okay, it won't let me access it. Well, this is where Docker saves this stuff. So on my computer here is where this information is saved, this underscore data directory that is in here. I can't access it if I need to access it, but it's saving the data there for it to be used. And again, you can find out where on your computer that data is being saved there. You can also change that mount point. Yeah, and then there's the name of it as well. And then scope is local, is just saying that, hey, the scope of this volume here is local. How do you access Docker volumes to put files in there? So you can kind of access it here. I'm actually interested in why it's not letting me access it here. Maybe if I sudo root, it will let me. I'll try that in a second. But I do think the stuff in the data directory is saved in an interesting way. So let's see. And I'm gonna try to cd here. Whoops. This is actual, so it's not actual contained volume. Yeah, there's a way to do this though. I know that there's a way to do it. Maybe if I ls this or cat it. It's just saying there's nothing there. Or maybe this is internal, docker lib volumes. Oh, you know what I bet the problem is here? I bet the problem here is the I think this is a Docker for Linux, Docker for Windows problem. Ah, there we go. I bet there's something in here. Mounts.data. So yeah, this, if you're on Linux, I do think you can take this and you can hop in there and do something with it. Let's find out real fast, actually. Just to make sure I'm not giving you any crap answers. And again, I think we should move over to this for this reason right now, just because like this is like it's showing that this is what it is, but I think it's doing some magic behind the scenes to work with Windows for Docker desktop. What's up, Stephen Yeet? Can you mount more than container to a volume? So to a single volume, you can mount any number of containers as you would like. If that was a question. And inside of a container, you can mount more than one volume. So there's a many to many relationship on both ends. So you can have, if you have multiple volumes, you can mount multiple volumes to a single container. And so the way that you would simply do that is adding more of these -v's. You get -v and folder. Folder. Yeah, so you could add just more -v's and you could mount multiple volumes into different directories. Yes, and multiple containers can mount to the same one. So yes. What is your favorite project that you have done while using Docker? So favorite, I don't know if I really have a favorite, because generally you know, you're Dockerizing applications that already exist. So like if you I mean, it's just Linux. It's not anything really all that special. It's just Linux. So I don't know, that's a really tough one. Like to me, they're just applications and they're all very similar, to be 100% honest. Do you know if it's possible to run X11 in Docker? So great question. There are ways to run X11 in Docker. There are ways to do it. It is difficult to do, and I don't think it works well at all. So be careful with that. Yeah, just be careful with that. But people have figured out ways to run X11 in Docker, but it's not like super compatible with everything. And like, I think only a couple programs work and things like that, but there are ways to do it. But I think it takes, a whole lot of stuff. What's up, girl.dev? Good to have you. What's up, Bright Iron? Good to have you. Xinglong 2020, welcome to the channel. The Mr. Software, also good to have you as well. All right. So is this starting up? There we go. There we go. No, we don't want to do any updates at all. What's happening? Let's do a host F really quick. View full screen. Oh no. I think it's broken. I can't even click into here. See, I told you my computer's giving me all kinds of issues. I do think it's the Windows update, to be honest. Let's try one more thing. Let's try to put it in like scaled mode or something. Yeah, it doesn't yeah, I can't even get in there. Super unfortunate. Let's see. Okay, we'll work with what we got. I was trying to remove that factor, but yes, I think if you're on Linux, I do think you can go to this mountain point and see the stuff. It might be in like a database form now. Like it might be like a database file instead of the actual files now, but I'm pretty sure you can go there. You can just go there and do it. But ideally you wouldn't want to mess with this folder itself. If you wanted to put data in that mount point, you would want to create a container that's mounted there, throw the stuff in the container, and then do that. She-Boss, again, thank you so much for gifting the sub to girl.dev. Thank you again for all the support. Girl.dev, please. She-Boss is a VIP of this channel. Please thank her for the sub. If you feel it in your heart, if you're appreciative of that generosity, make sure she knows how appreciative you are. All right, really weird. I don't know why it's bothering me so much. Okay, the point is you can mount directories to directories inside of a container, but you can also create these volumes, these managed Docker volumes that will keep this data around for you. And again, they'll sit around, and like when you're spinning up a bunch of stuff, you can accidentally make a bunch that you don't care about, which like we did ourselves, and Docker volume ls will show you those. So Docker volume prune will remove any ones that you have that are unused. It will remove those. So be careful with that one. I do not think that means, I'm pretty sure pruning does not mean remove ones that are empty. I'm pretty sure it means remove ones that are not currently attached to a container, running or not running. Pretty sure that's what it means. So be careful with that. And then to remove a volume, you can just do a Docker volume rm. And if I remove tester, it will remove that volume. So be careful with that as well, because it will remove the data that is on that volume as well. What does JQ do? JQ is not a Docker command. JQ is a JavaScript, not JavaScript, it's a JSON parser. And it just allows you to see JSON a little bit better. And so we inspected this, and we got this JSON output. JSON is JavaScript object notation, and it's a bunch of keys and values. It's a way to kind of codify data, and a good way to present data for machines to use. JQ simply allows you to parse it a lot easier. And so it also gives it some color that makes it a little bit easier for you to see the key and the value, but it would also make it easier for me to find information in there. And so I just think for our eyes, simply so we can see that these are keys and values that created at like this. To me, I actually wish more people showed me stuff like this, like just with some color when we're first looking at these things, because like this just looks wild to me, and it still does, just because like I've become accustomed to, you know, stuff like this. But yeah, just to give it a little color. But you do, it's an external application, you do have to download it. So you'll see me do that a lot whenever we're dealing with JQ, whenever we're dealing with any type of JSON, just again for the visuals. Yeah, yes, for your AWS CLI work, 1000%. And it's way more, like, it's super powerful for like pulling data out of big pieces of JSON. So yeah. Ooh, it did come with, oh, that's interesting, I didn't know that. Okay, that is volumes. We spent way too long on volumes, but no big deal, not a problem at all. Learned a little bit about I also learned a little bit there. Like I said, I don't normally do singular Docker run commands anymore. That's interesting. I think with the addition of volumes is, it's not new at all, but it's relatively new in the grand scheme of Docker itself. And so I think it's interesting that they have it kind of included in the same command, where it'll automatically create the volume. That's what I think, that's what happened the first time, is that it actually, because I specified the wrong directory, what it went ahead and did is instead was it created a volume for me without me having to create one first. So that's very interesting, something I didn't know it would do. Okay, volume mapping, Docker volumes, that's how you persist data. You basically, at the end of the day, all you need to know is that you need to connect a directory that's in the host machine to a directory that is running on the container, so that you can persist that data in some way. So now that we're past that, let's get on to the image management. This part is going to be pretty simple here. And so I'm just going to throw the commands at you, because this part is going to be pretty simple. We've already seen how we can pull an image, but we'll do it again in a little bit. But what are some things that you would want to do with images? You'd want to see which ones you have available to you. You want to get new ones, remove old ones. And so let's figure out the command that we need to use. The command that we need to use is Docker images with an S. I don't think image works. Let's see. Yeah, image is not a thing. Docker images is the command to list the images that are local to your machine. So all the images that you have locally on your machine and available to Docker locally is what it will show. And so, you know, I have a couple different images right here. Pretty simple there. And I'll just list them out for you. What's up, Colin Loritz? Good to see you. Loritz with a Z. I love it. Good to have you. So Docker images, how you see that. To get new images, you've seen me do this before. Docker pull is how you do that. And how would you find out where to go for images? You go to hub.docker.com. And from here, you can find images that you might want to mess around with, that you might want to use. And let's say I want a Couchbase. I don't want Couchbase, but I'm gonna pull it anyway. They'll tell you over here on the right how to get it if you need to. And remember, whenever you see a command like this, whenever you see just an image name like this with no colon in it, that means you are always pulling the latest. You're always pulling the latest tag. So you're pulling whatever image is tagged the latest, if you do not specify a version. And we'll start to understand versioning a little bit more tonight as well. But I'll do Docker pull Couchbase, and it goes through and it simply downloads everything I need for Couchbase. I don't need Couchbase. I'm actually gonna stop it. Don't really need it right now. And what that'll do is, because I stopped it, it's actually going to, oh, okay, yeah. Sometimes if you interrupt things, it will actually give you something like this, where it'll be tagged as none, which is kind of annoying, but that time it just cleaned up everything and the download didn't matter because I stopped it. But you download an image, you can do a Docker images, and you'll be able to see it here underneath your images. So you see your images, Docker images, how you do it. You need to get a new image from a repository, or from a Docker registry. You do a Docker pull and the name of that image, and that will pull it locally to your computer. And then if you need to remove a Docker image, remember to remove a container, it was Docker RM and the container ID or IDs. And to remove an image is actually Docker RMI. So I know they're pretty close together. Yeah, I know they're pretty close together. So you do Docker RMI, so remove image. So this is a container. This is for an image. Very too, a little too close for comfort sometimes. And you can grab either the image ID or you can grab the name. So the name or the image ID is what will work. And so I'm gonna remove this one right here. I'm gonna copy this. I'm gonna say Docker RMI, this image ID. And when I click it, it goes through, gives me a couple lines of things that are deleted. And if I do Docker images again, that is no longer here. That image ID is no longer here. There were 5. Now there are 4 here, and that one is gone. Now, what happens if I try to remove something like Ubuntu? I try to remove something like Ubuntu. It says, oh no, I get an error. It says error response from Damon, conflict. Unable to delete this ID, cannot be forced. Image is being used by running container, and it gives you a container ID. So when you are removing images, you need to be sure that any and all containers that are referencing that image are gone, are deleted off of the machine. All right. Why is that? Why do all the containers referencing it have to be removed? Because containers, when they die, they don't go away. They are still there on the computer, and they can be started and stopped. But that base underlying image needs to be there for it to do these things. And so if there's a container in place, whether it's running or not, it needs to be removed from the system. So what I would need to do is, luckily it only tells you one. If there are multiple containers running with that, using that image, it won't tell you all of them. It'll just tell you that one. So I've seen people like go through and start deleting them one at a time. You don't need to do that. But I'm going to stop these, and I'm going to try to do that RMI again. And when I try to do that RMI again, it still does not work. And notice how it changed. It says image is being used by running container up here, and now it says image is being used by stopped container here. Same container ID, but this is just to prove to you that the container, whether it's running or stopped, it needs to be removed from the system. And so how do we remove something from the system? We need to rm. We need to use the Docker rm command. And this is going to remove all of them for us, but we need to do Docker rm and the container name or container ID, and that removes the container from the system. And now we can remove the Ubuntu image if we would like, and we can confirm that by doing Docker images. And I cannot spell. Images does not have an H in it, and no longer is Ubuntu here. So I'm going to pull it again, just so we have it, because we're probably going to use it a little later. But that essentially is really the mainstays of the basic image commands. There's some other things that we might want to do with it. So that's getting things that already exist and managing images that already exist. One other big thing that we're going to need to do is we're going to need to push images sometimes to container repositories. So tonight we're going to learn about building images, and so sometimes you're going to need to, let's say, make a change to an image. So actually, let's do another run command with Ubuntu. I'm actually going to remove this. I know, because that's not going to change anything. But let's say, let's say I built a brand new image, and I'm going to teach you this thing later. Don't worry about it. Docker tag Ubuntu. I need to tag this. I actually have in Docker Hub. I actually have a space for this. I shouldn't do this, but I don't really care about the stuff here. All right. My username, I'm going to tag it as this because I want to push it here. Docker tag Ubuntu as this image. And so all I did was basically add a new I basically created a new image just now based off of Ubuntu. That's basically what I did. Basically just tagged the Ubuntu image as mine. Now you might want to push this up to your own repository or to a repository, and the way that you do that is you must first log in to the repository. And so, oh, actually tag images was here. So you can tag images from other images. Why would you want to do that? You know, naming, there's a number of reasons, but you know, mostly just to use different names for them, or you incorrectly name something. It's just a way to change the pointer to that. The old tag does not go away, but it does create a new tag. And so that's what I just did here. Docker tag one image name, and you give it a different image name. So if you want to change the version, and I say, hey, maybe I forgot to change the version of Ubuntu, let me go ahead and retag this with a new version, you can go ahead and do that, but it just gives it a new name, really, a new image ID. And so once you do that, if you want to push it up to a registry, you have to first log into that registry. And so we're going to push up to Docker Hub really quick. And the way that you do this is you simply type in Docker login. And when you type in Docker login, it's going to try to log into whatever registry is configured. Again, by default, it will be the Docker Hub. And so what you'll do is you'll enter in your information. And I don't know my information offhand. Let me grab it from LastPass. Let's copy password. I hope it doesn't show the password. Let me check let me move it off screen real quick. But you put in your username, and so you'll see me type in mastermind IO, and it shouldn't show you password. Yeah, it didn't show it. Cool. But it gives you a login succeeded once you do that. So Docker login will allow you to authenticate with the registry that is set up by default, and this one is Docker Hub. Type in your username, type in your password. When you type in password, it will not show you your password. This is how Linux works. So don't stress when you're typing in if you're not seeing things typed out. It is typing, it's just not showing it to you. And once you've authenticated, it says login succeeded. And now, and only now, can I push this up. I would not have been able to push this up before. I don't know how to, can you log out? Can I do like Docker log out? Okay, I can do Docker log out, good. So what I'll do is I will do a Docker push, this, and I just want you to see that it says, hey, denied, request access to the resources denied. And that's because, again, you have to authenticate. So we'll log in again. I'll grab my password again from LastPass. And we get logged in. And if I do the push command, so Docker push, it will push that image up to this repository, and everything looks all good. And if I actually go here and I refresh, it'll say updated a few seconds ago. So that's how I get images into this location, into this registry. So Docker pull to get images locally to you. Docker tag is how you create it, like you tag an image with another name. So if I want to say Ubuntu latest, if I want to say, hey, Ubuntu latest, I think it should be tagged as Ubuntu version 4. I can retag it as Ubuntu version 4. And if you want to push it to a registry, you have to first log in using Docker login, and then you have to do Docker push and the name of the image you would like to push. I always thought From was the OS, but you can layer containers. From is not the OS. Well, From is not the OS. And yes, you can layer. You cannot layer containers. Images have layers. From is the base image, but yes, you can't really layer containers. I mean, if you think about the From as layering, you can layer pieces of container images, which I guess create containers. So it's a little weird when you with the nomenclature, but yeah. So that's image management, like, as a whole. You can see your images with Docker images. You can pull images down. You can remove images with Docker RMI, so Docker remove image. But make sure that all containers that are referencing that image are removed first, or else it will not work. You can tag images here, and you can log in and push them up. So that is container image management. Now we're into the cool stuff. This is where I think you'll have the most fun. So like I said, if you don't have a text editor downloaded, I recommend you download VS Code. I put a link in the Notion, so if you do !contained, I put it here. VS Code is what I recommend if you do not have one, which it'll allow you to, edit text easier and more fluidly. It'll give you some tools to make all this pretty simple. Have I ever worked with Windows containers? I have not. I have never worked with Windows containers yet. I haven't even worked with Windows in, maybe 5 or 6 years. I haven't worked on any Windows, like, server systems or any Windows systems. But I have not. So I'm not even sure. I'm not sure how different they are. I'd be interested to try some out. They suck. Interesting. I mean, I think I heard that before a long time ago, and I thought it would get better. Windows is just, it's kind of heavy. And just the way that it works is just, the paradigm seems a little bit different, a lot different actually. So I don't know. All right. They're lightweight Hyper-V. That makes sense. That makes sense. It doesn't sound great when you say it, but it makes sense. Okay. Dockerfiles. This is the most fun part to me. This is where your power lies. But at the same time, generally, I was really worried about this when I first started learning about Docker. I was like, I gotta basically learn how to learn this new coding language. That's what it felt like when I first learned Docker. And a little bit, kinda, but it's pretty simple. I don't want you to forget that Docker containers, Docker images, they are just Linux. So everything you're gonna be doing here is basically just Linux things. So the better you are at Linux, the better you probably will be at writing Docker files. Learning how to write Docker files themselves is actually pretty easy. The hard part is, the hard part about creating Docker files for applications that aren't super familiar with, or is that you need to have some Linux chops to be able to build them properly and to know what's going on. But yeah, it's just Linux. So the better you know Linux, the better that you will be at writing these Docker files. Oh my, the average image for server core based images, 3.5 gigs. That's wild. It makes me uncomfortable. Whenever I even get to images, like the image is a gig, I'm like, ooh, this is painful. I feel icky just reading that, to be 100% honest. Okay, so what are Docker files? We talked about it before. All it is it's the instructions to build a Docker image. So you write the instructions to write the Docker image. And again, you're writing in a text file, you write some text. These are the instructions that Docker takes in, and it builds an image based on the things that you wrote in this file. Almost as bad as Node. I don't know how big the Node one is. But the Node itself is probably not that big, but all of the dependencies, for your application, might make it huge. Okay. So Dockerfile anatomy. This is going to be very high level. Yes, no packages. The actual packages get pretty wild. I don't even want to talk about how large ours is for our project. It's out of control. But Dockerfile anatomy, and really for anatomy, I just want to show you an example of what one looks like. And I actually really hate that they didn't put spaces in between these, but I do like that they didn't, because it allowed for me to take a screenshot and stick it right here, so that you could actually see. But what you're gonna get is a bunch of these, again, this is why colors help, but you're gonna get all these capitalized instructions here over on the left. And they messed up actually, but you get all these capitalized instructions over here on the left. And these are each of these lines. Whenever you see one of these capitalized instruction words, this begins kind of a new piece of the Docker file. So it's kind of like a new section. And what you're always gonna have is this from up here. You're always gonna have this line up here. And then everything else is pretty fluid in between here. You may have a Docker file with all these things are not necessary. From is the only thing that's necessary. And I think that you have to have either a CMD or an entry point. I'm not sure. We will check that tonight. I can't remember if you have to have one or not, but it feels like you should have to have one. But everything else, it should be capital CMD, and it could be in the way that you wrote it. There are other formats for CMD as well, but all the stuff in here is variable. So like any of the stuff could change. I could also have 10 of these copy commands. I could have 10 run commands. I could have 100 run commands. I could have all these things. You can only have one CMD. You can only have one from. We're gonna go through these in a second, but the anatomy basically is gonna start with from. There's gonna be a number of these commands in here, and it's generally gonna end or be kind of closed out by a CMD or an entry point. But this is just one. I kind of wanted to show you what one looks like. And again, it could be much longer than this, or it could be even shorter than this. And so now we're about to get into what each of these things means, and we're going to start actually building out some Docker files starting right now. So get yourself a text editor. I'm going to do it in Vim, but you should do it in VS Code. I'll do it in VS Code just for you all. I'll do it in VS Code because I do like VS Code's Docker extension. If VS Code is even installed on here, which it should be. So before I go with this, I see some questions. Oh goodness, I think it depends on if you're, yes. So yes, syntactically, if you're using Compose, it's going to be different. Yeah. So should the workdir also be the volume mapping location? Great question. We're gonna get to workdir, but no, maybe it depends on what you're doing. Probably not, to be honest with you. Your workdir probably shouldn't be the volume mapping location, but we'll get there in a second. So there is a reference file in Notion here that has all these things. So Docker has a pretty good reference file for building Docker files, and you will reference this. And so I'm going to paste this in the chat. So I want you to have it available to you. I want you to have it up, and you can see here over on the right, there are the things that we're going to go over that you can click on and see what these things do. But again, I do understand the technical documentation can be tough to parse and to understand. It takes time. So we're going to be going through these things, or most of the ones that I think are pertinent to learn right now, not every single one that are common. So let's start going through these really fast. So from is what your Docker file is going to begin with. So using the from command or the from instruction. And what the from instruction does is it specifies an image to base your image from. And so I am going to open up a file. So you're using VS Code. Let's see. Do I even have it installed? I think I do. All right. So I'm using VS Code over here. Probably super out of date. First things first. What I want you to do, if you are using VS Code and you don't have the extension, head over here to the left and find the little extensions block. Click on it, type in Docker, click on the first one, click install on the very first one that comes up, and that will just give you some extra syntax highlighting and tools to help you build Docker files in the future. Not going to be super important right now, but I do want you to have it. I think it'll be helpful. So I'm going to create a brand new file. So I'm going to create a new file here, and I'm going to call it Dockerfile with a capital D. Yeah. This is commonly what you'll see Docker files called. So what's interesting about Docker files in particular is that it goes against the naming convention that you're used to for files. So Dockerfile is actually the extension, and so that's why it knows it's a Docker thing here. But you can have multiple Docker files in the same directory, and you can split them up by doing a dot and then maybe I want to call this one Nginx. And so it takes on the like the name that you would normally associate it with afterwards. So capital D Dockerfile, and do a dot in the name. Yes, it is like Makefiles. But yeah, I've seen it be pretty confusing for people the first time around. And so they're always gonna be called Dockerfile. And then again, you can give it a dot, whatever name, to if you need to differentiate more than one Dockerfile. So Dockerfile is what we're gonna call it. Just call it Dockerfile. And the first thing you're gonna do is the from command here. Make this larger, close this down. And because I added in that the thing, it should, I thought it was gonna tell me what it was, but we already know what from is. And so I can specify a base for a base image to start working from. So I don't have to start from scratch. And so I can base mine off of Ubuntu. And you can be very specific. You know, if I want to use Ubuntu 16.04 or something, I could, but I want Ubuntu latest. So I just put from Ubuntu. And this, again, when this goes to build, it will use the Ubuntu image as its base. It'll start from there. And so that is going to be the first line of your Dockerfile from whatever image you want to start from. Now, the next command is that you can have. These are in no particular order, besides from. Everything else, there can only be one from, but there can be many of these, unlimited of these. And this is probably the most common command you're going to do. And what this is going to do is it's going to run a Linux command. So what I want you to do is I want you to think about this Dockerfile as basically a script that does the things that you needed to do to get a program or application installed and up and running. And so what's the first thing I said we need to do? If you've been watching Waddle, when you install a new Linux system, you know, you're messing around with Linux for the first time, you bring up a new system in the cloud or something, the first thing you need to do is update it. And so the run command simply allows you to execute Linux commands. And so this is, you know, this container will be a Linux container. And so we can just run normal Linux commands. And so this is Ubuntu. So I can do something like this. apt update is a Linux command. That's one command, and I could do a run. Another one, and I could do apt upgrade. I could try both of these. And these are some things that we could do. I know someone's gonna hop in and say, hey, you can put those on the same line. Hey, you do the add dash y. Hold on, we'll get there. Wanna show some things first. But so I could also, I could run any Linux command that I wanted. I could run, any Linux command here, and that instruction will go ahead and run that during the build process. So the build process basically takes the image here and spins up a container to start building from, and it starts to execute these instructions against it, so that you can get to whatever your end state or end goal is. Okay. Ooh, sorry, I did not mean to do that. All right, so run, cool one. You'll use it a lot. Again, you can have unlimited run commands in your Linux, in your Dockerfile. CMD. So we saw that in the example file earlier, but CMD sets defaults for running in the container. And this can be very interesting. It can also be used to set what executes when the container starts. So remember, containers are designed to run a singular process, and so when they start, they run from a singular process. You can actually set that process via the CMD instruction. There can only be one CMD. Now, you can put more than one in the Dockerfile, but only the last one will be executed. So only one. So maybe I'll put a little only one here, and maybe an only one here. All right. CMD does this. What is this? Docker login. I don't know how this got in here. All right. So label is another one. So CMD allows you again to specify some container defaults. we'll get there. I actually think the hardest things to understand about Dockerfiles are the CMD and entry point commands. Everything else I think is pretty straightforward, and their relationship, they have a little bit of a relationship here. So let's see. Label is going to be basically add some metadata. So metadata is just some little text information about the image, and you can use that to, you know, to query or find, you know, certain images. You know, it's just a little bit of extra information for your own uses, for organizing things as well. So label, I don't use labels often, to be 100% honest, but we'll add a label, and again, it just looks like I'll show you what it looks like. Because these things work in JSON, it's just some keys and values, some key value stores as well. So label, you can label, you know, whatever you want, version 1.0, description, this illustrates text. So again, it's just adding some metadata to the image that you can, you know, to describe certain things, or that you can use for organization or management of these things. And I don't use these personally very often at all. So I'm not even going to show you that. I'm not even going to put that in our Docker file right now. All right. Now, add and copy are probably going to be the next most popular ones for you after the run command. And so these allow you to do a couple of things. So add actually allows you to copy files into the image from the host machine. So while this image is building, let's say, hey, maybe I'm using some images that are locally, maybe I'm using some, you know, I need to get my application code into the container. How do I get my application code into the container? I can add it in there if I would like. There's also copy. Copy is the one that just does that. Copies files from the image host into the machine. Add is the same thing as copy, but add some extra features. It allows you to actually add to a container from a remote URL. So it allows you to download a file from a remote URL into a directory that is on the machine, or to extract a tarball file as well. So it's actually really nice. So let me go to like Google, and let's go to funniest meme ever. I'm gonna click on cool. You know, babies are you know, pretty safe bet. You know, that's not gonna be anything too crazy. Then I told the officer I can't even walk when I'm sober. Haha, it's funny because it's a baby and babies can't walk. As long as we can take this, the add command will allow you to do something like this. It'll allow you to add, and I think I can just do the URL, and then I think I can give it the place that I wanted to put it. So I think I can just do like the home directory, and so it'll it might need a colon in between there. I never remember the syntax here. I always have to reference this reference, so please feel free to do so. Source, then destination. Yep, so that seems to be right. They give me the examples of URLs down here, but yeah, it'll be something like that. Whoa, went too far back up, and my computer's going slow, like real slow. But yeah, so add allows you again to do the same thing that copy does. The main goal of it is to copy a file from the local machine into the image. But add allows you to do some cool stuff with remote URLs as well. And so for copy, if I had a file, let's say I had a file in this directory, I could just say, hey, copy this file .txt into the server onto like again, home files / this file.txt or something like that. And so basically add from the source to the destination, copy from the source to the destination. And so any files that I would need to copy in, I can go ahead and do that. Before you run, it doesn't copy on every image build. Before run. Oh, okay. I got you. Oh, yes. So we're going to talk about layers and ordering shortly. Add is risky. Why is add risky? Yeah, why is that risky? Are there ways to make a link, like a symbolic link? Yes, there are. Yes. So do you mean a link from the host machine to the, so the way that you would make a link from the host machine to the container is to link volumes. It's to link volumes where that file is. And that's how you would make a link. You wouldn't make a link to an actual file. You would make a link to the directory that they are in. Use copy instead of add. Arbitrary URL specified for add could result in man-in-the-middle attacks. Sure, absolutely. I do agree with you. I mean, you are not wrong, but add itself is not inherently risky. Again, the arbitrary usage of add is what is inherently risky. Cool. Add implicitly unpacks local stuff, which may not be expected and results in path traversal. So, and then there's a lot more. Yes, add does do that, and it's specifically to handle this situation. So yeah, I mean, add sure. Yes. I want you to know. I do want you to know what add does. There are a lot of Docker security best practices for a number of things, but zero trust. I get it. I definitely get it. Sometimes you need to copy from a URL, though. There are better ways to copy from a URL. I do not copy from URLs using add. There are better ways to copy from URLs. What's up, Aya? I appreciate that. To a little question, but how will volumes work with a database server? Like if an application is working, oh, great question. So I actually don't recommend using a containerized application for something like a database. It will work just fine. But it can be really weird on startup and shutdown if you have to do that. I can get into real weird states. But yeah, I mean, for something like a database server, yeah, you simply have to mount the main data store to the right place. That's all you got to do. Like for like MySQL, like all the stuff is like in var lib or something like that. And you just got to mount it properly. It works. I highly recommend that you don't do it. I'd highly recommend that you don't do it, to be honest. Seems to be common for installers these days, but it scares me. Curl random site sh to bin bash. Yes, that is more so the path that I take. But like things that I wrote to do that. So I've not worked with LXD stuff. I have checked out Firecracker stuff. I love the idea of Firecracker. I haven't found a good reason to use it yet. Yeah, I've not found a good reason to use it yet, but I do want to check it out. It seems pretty cool. I was pretty hyped when I first found out about it. Using SCP between systems on home. I think the thing is, generally I'm not doing anything wild that I even care if people were to do anything with. Yeah, it depends on what you're working on. Okay. So those are some more Dockerfiles. Oh wait, actually we have more to go. So add and copy. If the goal is to get something from your host machine into the image or from somewhere else into the image, these will help you do that. env sets an environment variable. These are very important. You want images to be configurable, and environment variables is a good way to make them configurable. And so this will set an environment variable. For anyone who doesn't know what an environment variable is, a variable is just a kind of placeholder value that can change. And so if I make a variable that called name, I think we did this last time as well, but if I say name equals Aaron, and I do echo $name, it will print out Aaron instead of name. So like this variable is holding a value, and that value can be changed. So I can change this from Aaron to Leroy. And if I print it out again, the value changes. It holds a value. And so if you want to configure one of these things, you can use it for all kinds of stuff, from passwords to usernames to different configuration settings. That is how you would do that. So you would do something like this, env, and I think it's simply like, I want to say it's like name equals Aaron. I'm pretty sure it's exactly the same. It might be a colon. Again, I never remember the I have to look this up every single time. It's just key and then value. Oh no, you can't do it the way that I just did it. A couple different ways, either key and value or key equals value. So exactly what I just did there is fine. And so you can set any number of these. So I could say, again, env age equals 30 and so on, and these values will get built into the image, and these values would end up being used later on. What's nice about these is you can set these up. You actually don't need to specify a value, and you can use other things to pass in values for these at runtime, and you can use them to, again, configure certain things. So maybe you have an application where it needs like a database host, and you can set the database host equal to whatever the host is. So just set it up to myhost.com, and maybe you have a database user, and that database user is DB user, and you can pass in password stuff. And then what you can do is, in your application files, you can use these variables instead, because they may change from environment to environment, or from, you know, whoever's using it, they may change. They probably will change. So that's what env does. It allows you to add environment variables. Expose allows you to expose a port. Remember, these are isolated from the host machine, and so if you need to expose a port, so again, if we were installing a web server, we would have to do expose port 80 and port 443. I think you can do them in one line like this, or maybe like this. Maybe it's like, I don't know how you do multiple ones in one line. I think it's like this, but you can have more than one expose command. We can look on how you do multiple ones here. Yeah, okay, so I did it. Oh, you need to add the protocol as well, TCP or UDP. TCP is what you want. I think it defaults to TCP. By default, expose assumes TCP. Yeah, so you don't need this. TCP is what you want. You don't need to do that. You don't need to do that. Can I run tests in the Docker file? Yes, but you shouldn't. I don't think you should, but you can. Loggings. So are you, well, hold on. Let me backtrack a little bit, because I may have, the way I'm thinking about your question may be wrong. Are you saying, can you make a Docker file that runs your tests? Or are you asking, you know, like, when I build my application in Docker, should I run the test as a part of the Docker file? Because that part is no, but yes, you can run your tests in a Docker file. A lot of people do. That is kind of how all the CI platforms work nowadays. All the newer ones work that way. I think so. You can copy variables from the profile with braces too, right? I'm not sure what you mean there, Harold. Copy variables from the profile. Not sure what you mean by that. When you do 880, yep. And so what this will allow you to do is, yeah, when you do that port mapping, what we're working on now, when you do that port mapping, unless these are exposed, you can't really do that mapping, because you know, Docker won't know that this port will be closed down. It won't be open. So exposing it, again, doesn't do anything to the host machine. It exposes it on the container level, and then you can map it later if you'd like to map it. But if you have a protocol running, and you need a port exposed, this is how you would do it. So what's an environment variable? So that's what environment. Oh, perfect, Asheroth. Yeah. So expose and then entry point. Now this entry point and command, like I said, are probably the two hardest things to understand about Dockerfiles. Entry point. What is an entry point? Entry point is there to allow you to configure the container that's going to be booted up as an executable. And so this is one of the things that helps you run this indefinitely and helps to set the startup command of the container, like where we entering this container at, and it's at this executable. And so if you omit, you can like omit this with a CMD. There's like you can have both a CMD and an entry point, but you don't need both. Depending on what you're doing. Again, CMD is really for defaults, but can perform this action as well. So it's pretty interesting. But yeah, it allows you to start up as run it as an executable, which is kind of cool, I guess. But yeah, it looks like this. And so basically you're gonna give it a you can give it, these are a little bit interchangeable, but you give it a command to start with. So look at this. Let's actually take this Docker file right here. Let's take this Docker file right here. I like this. This is really good. And we're going to jump ahead basically because you don't know about build yet, but I'm going to redo all this and we'll take this right here and take a look at this Docker file real fast. Let's take a look at it because I think we know some of this stuff, but from Ubuntu, that's the line that we had. So it's going to start from there. The entry point is actually going to be top -B. So this is the way that this is written is this is actually just breaking up command line parameters for the command in different pieces. So this is actually top-B. This is what it's referring to. It's saying, hey, run this. And it's just, you have to break up the different arguments by commas. By commas. They have to be split up here. And so I'll run that. And so top is running. This is what top looks like. Top is an application to show you information, real-time information about your computer, about your computing resources. I don't know what the -B does. Top -- help. Top just one. Okay. Man, I want to know what that does real quick. I don't, because I have no idea what this -B does, but it looks like it was creating new things for me. Bold highlight. I don't. Okay, great. But what also is in there is this CMD option, and so this is setting up a default as well. So this -C is actually going to be there as well. But the entry point can actually they can do some overriding of themselves. The CMD can do some overridings of these things. So it's actually going to I don't know if it's going to run B, C, or just C. But let's see. Let's actually build this and run it really quick. Docker build -T test run. Did they give us a specific run command that they want us to use? Yes, they did. They gave us a specific run command. What? Oh, I call this test. Nope, that's the name of the thing. Test run is what I called it. And now it's running what we're supposed to, what we just built and we're supposed to run, utilizing both the entry point and the command. So it is running that top file, and the command in this case sets some of the defaults, sets up some of the defaults here. And so that's the main purpose of CMD. They put this here because people use CMD in place of entry point pretty often. And it says these defaults can include an executable, just like entry point can, or they can omit the executable, which in that case you must specify an entry point in the instruction as well. So if it does not have an executable, you must specify an entry point. So you know there's common times you have both, but it can also just be done with a CMD as well a lot of times. Regex Generator, thank you so much for the follow. Good to have you. What's up, Wasser? Type Theory. Plopper 4, Vladimir Cabrera, Loggings. Welcome. Good to have everybody. Glad to have you on the channel. Glad you're here to learn a little bit about Docker as we're running through some of this stuff. Okay, so that was that. And then these are probably the last three that I think you should care about. For now, there are more. You do not need to memorize these right now. You don't need to be a pro at these. I want you to hear them right now. I want you to hear what they're about, so that you kind of know the things that you can do when you're building a Docker file. And so look at this one, workdir. Workdir sets the working directory. So again, when you start this build process, it's going to basically spin up some containers and start to do some real, it's going to start to execute these commands against, you know, a real container. And so workdir sets the location in which you are currently working. You can also achieve this by doing a run CD as well. So in this Docker file, I can say, hey, maybe I'm building a couple things. Maybe I'm running an apt update. And then maybe I want to, you know, download something from the internet. And so maybe I'm doing like a run, and I'm doing a wget of random image, and I'm downloading a random image .png, and I want to download that to a certain directory. And so with wget, you can do that in the command. But if I were to just do this right now, it would do it from the root directory, the root home directory, and so it would download it into the wrong place. Maybe I want this in a specific place. Maybe I'm running a bunch of commands that I want to execute, but I want to execute them in a certain space. So workdir says, hey, do all of this work in var www HTML. It says, hey, all the work after this, go ahead and switch your working directory here. Change the directory that you're working in to this space. And so all the subsequent commands will be run from this location. This is where we'll execute them from. You can achieve a bit of the same thing. You got to be wary of it. You can do like a run CD and then do like a and then run your code. So there are a number of ways to get these things done, but workdir is what I would use, and it sets the working directory. You can have multiple workdirs. Every time you run one, it changes. So if I want to do some stuff right here, but then later I want to do something in var project, I don't know, in a different thing, everything after this would run in this directory as well. So yes. Some comments, BS batch. Okay. Move workdir also tells the container runtime what directory the command or entry point should see as the current working directory. Yes, it does do that as well. Yes, that is super helpful. It's super helpful. It's interesting because when I first learned about workdir, I didn't understand that paradigm. It made sense, but I remember building something out, and it worked just fine the first time, and I couldn't figure out why it wasn't working when I wrote a similar Docker file like later, and it was actually because of that's when I found out about that, because I wasn't using workdir in this new one because it was a different project, and the executable on the entry point was like, it didn't know what to do. It also creates a directory if it doesn't exist. I learned something new. I didn't know that. That's pretty cool. We'll try that out. I've never seen that before. That's kind of nice. Should I install dependencies in the Docker file or add or copy it? Great question, Loggings. Excellent question. And this is all choice. This all has to do with what the application is that you're installing. Generally, people install them in the Docker file. There are scenarios in which it makes sense to copy them in. Those scenarios pretty much only exist in the cleared space, to be 100% honest, or like especially if you're working in an environment where you can't build these things using the internet, which is actually a thing. But generally, you'll want to install these things now. We're about to learn about layers, which will help mitigate some of your fears and worries there. But yes, generally you're going to install them in the Docker file rather than copying them or adding them. Yeah. So that's work there. And user sets just the user or group to use when running the image, to kick that off with. And then volume just creates what we were talking about before, creates a host mount directory in the container image that allows you to specify a mountable space there. Is there a better way than running all the app stuff? Phenomenal questions. I love these questions. Yes and no. It depends on what you think is better, and each situation I think determines what better is. And so when you're done writing a Dockerfile, you do build it. You saw me build it, and what you do is use a Docker build. And this dot here is there for a reason. It's not the end of the sentence. You have to tell the computer where your Dockerfile is. And so you saw me do our build. You saw me do Docker build -t says go ahead and tag this. It's set in the name. It's saying tag this image with this tag. And then dot says, hey, I want you to build from the context that's right here. And so we're not going to dive into context really, but it says, hey, right, like my Dockerfile is right here, build from this location. And yeah, and you can also, there's other things you can pass in to do builds, but a basic build command looks like this. You do not actually need the -t. You can just build it without it, I'm pretty sure. Like if I can build it again by just doing this, and it will still build it. And I think it just doesn't tag it with anything. The Docker images, we can see the test run that we already did. And it actually didn't do, it's because it's already built with this. It didn't do anything. But yeah, Docker build is the way you do that. And that will create the image for you to use from now on. Now, let's talk about layers first, and then we will talk about your question, Harold. Layers is an interesting concept. Layers is something I actually really truly love about Docker, but layers are just intermediate changes in an image. And so you've seen layers already, didn't know what they were, but new commands create new layers. Not all commands create new layers, but a lot of them do. All of your run commands, all of your copy commands, all those middle commands in there, they create new layers, new intermediate changes. So every time a run happens, that creates a new layer. And then so when it gets down to the next run, it creates a new layer for that thing. These layers are represent the changes that are happening in that Docker build. And so what's great about creating these layers is Docker will reuse them. So layers can be cached and reused to build things faster. So when we downloaded, let's download Couchbase again. Docker, pull Couchbase. All of these right here are layers. That's why it's doing a bunch of different things. These are different layers, and layers are reusable. So if we actually looked at the Docker file for Couchbase, which we can do right now, it will match up. There will be a match in the commands that are in there to how many layers there are. And again, these layers are individual changes to the Docker image, and they get pulled together, and then they get pushed, they get built together to create a singular image. What's great about these is when you make a change to the image, it only changes the image, it only changes the layer that changed, and subsequent layers, those have to get rebuilt as well. So it's very interesting. You can do some interesting things with this. The way that you build your Docker files can severely affect your build time. You can do a lot to make your builds so much faster with the way that you layer your container together, because again, it's only going to build what changed. Once it builds once, it's only going to build what changed. And so what we can do is, let's actually go look at Couchbase in a second, but it's very interesting. It's a very interesting concept. And it's also worth noting that different images can utilize the same layers as well. So like, I don't know what this layer is, but if this layer, you know, is something built on Ubuntu that has one thing installed or something, another image may use that same layer, maybe. Doesn't really happen all that often, but it's possible for it to happen, because, you know, whenever you're doing custom images, it gets interesting. But these layers are super nice. Yes, just like commits in a branch. If you're familiar with Git, it is very much like commits in a branch. And every time, you know, you do a build, utilizing a new command, it will set up that commit properly. If you update that commit, that commit will get updated. It's a really interesting concept, and layers are super nice for that. And we're about to see kind of how those work. They can be cached and they can be reused for building faster. So what we're gonna do is we're gonna go to hub.docker.com. and we're gonna grab a Docker file, a bigger Docker file for something. So let's, the Ubuntu one is small. Let's check out the Node.js one. Node.js Docker file, what does it look like? All right, someone brought up Node earlier, so this is actually great. This is a bigger Docker file than I wanted to do this with, but I think it's gonna be interesting, at least just to look at. Okay, we can go ahead, and this is the official Node.js latest Docker file. We pulled it straight from GitHub. It's available to you, because these are public images. And so it's got a lot of Linux stuff in here that might stress you out a little bit. But as far as Docker goes, it has a from, it's got a run, an environment variable, another run after that, another environment variable, another run, a copy, then it's got an entry point and a CMD. All right, and so we can actually build this. I don't even know why I copied this in here. I actually need to clone the entire repo, or else it will not build. Node, let's go ahead and code. All right, CD was a 14. What file was that in? Docker node. Oh, I didn't change into that directory first. Docker node 14 stretch. Okay, so we're in this file, and this Docker file is right here. And this is the same thing that we were just looking at. Bunch of different things. I'm gonna build this really quick. So Docker build -t. I'll call this contained underscore node.js. I'm gonna build it right here. And it's gonna go through, and notice how it says step 1 of 9. How does it know what 9 steps are? It knows because of these commands. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is how many steps it has to do. And it's going through, and each step is breaking up into its own thing. And that's because these are their own layers. Each of them is breaking up into their own layers. Again, not every single command breaks into its own layer, but most of them do. But not every single one does. And it's going through and it's doing each one. Now, what's great about this is, let's say some of these steps take much longer than others. Let's say that one of these ones that takes a long time, like the one that we're currently on, let's say maybe this one finishes, but the one after it fails. What's nice about the layers is when I go to rebuild it, if I didn't change anything, like if I haven't changed anything about these first 3, it will not rebuild those things. It will not need to rebuild those things. It'll say, hey, I have this already. I have this layer available to me. I'm gonna go ahead and just use that. I'm not gonna rebuild anything. This saves you a lot of time. Same thing for these bigger ones, you know, as long as nothing has changed in them, it will simply not build them. It'll use what's already there. It will only build what has changed and after. So after this is done building, maybe I'll try to change something so we can see what that looks like. But it's only going to change that and the stuff after, which is kind of nice. And you can use that to your advantage. This means now that instead of going through, let's say we had a Docker file over here, and we had a Docker file, all this stuff. Maybe we did a from Ubuntu, and then maybe we were installing everything one by one. Maybe we were doing an apt update, and maybe we're doing a run apt upgrade. Maybe we're doing a run apt install nginx, run apt install php. I don't know, maybe you're doing something like this, and that kind of sucks. This is not really good. You can start to layer things together. Each of these creates its own layer. Each of these will get rebuilt. Will get rebuilt. What you can do is you can actually put these in one line. Also, hello Pachi Codes, welcome to the channel. Thank you so much for the raid, all 17 of the raids. I don't actually know why it didn't ding in my ears, so hopefully, I don't know how long you've been here, but welcome to the channel, all Pachi Coders. Thank you, welcome, shout out to Pachi Codes. I'm gonna spell this right first time. Codes, welcome. Good to have you. What were you all doing over on Pachi Codes stream tonight? I'll definitely have to check this out. Let me first off, you are my friend now. Well, I request friendship, but I'll definitely check out your channel. It's pretty cool. Thank you so much for the raid. We're learning a little bit of Docker tonight. We're doing a 3-week series in Docker, so you missed the first week, unfortunately, but we are, we're just building out some Docker files right here. Oh, doing some JavaScript. Well, I'll have you know that right here, currently it's going slow or it's broken. We were building the Node.js container. We're building the official Node.js app container. I don't know, that should have worked. I don't know why it's getting stuck there. Now it's not. Oh, keys received failed. Oh, keys found. Oh, now it's working. So now we fixed it. Thank you. You came over here, Pachi Codes, and you just by your sheer presence, you fixed our problem. So we're actually building Node.js, the official Node.js container over here. And so it's done. It's actually all done, which is really nice. But what I was saying back up here is what you can do is you can start to format the way that your Docker files are built by doing these in single lines. And I could say and slash, just to make it a little easier, apt upgrade. And I could do it in one line, but I'm just making it a little better for you. And apt install nginx and all the dependencies, and you can put them in one line, and all of your dependencies could be created in a singular line like this. See, there's only one run command, lots of commands in here, but a singular run command. This counts as a singular layer. No matter how many things I have under here, it's a singular layer, and that is how you can manage part of that. I think Harold, you were asking something about that. That's the best way, and the layer will stick around. Now, if there are updates that need to happen, you can force updates and stuff. It's real weird, but it will save this layer for you to use over and over again. It's probably the best way. The other way that you might want to manage not having to do this is to have a auto build. Something that keeps your dependencies there, and create an image out of that, and then use that image as the from container, as the from image source. That's another way to do it as well. There's so many different ways to build it. It's really annoying. Is there a limit to the number of layers that one can have live at once? I don't think so. Not that I know of. I think it's dependent on how powerful your computer is, but no, I don't think it matters. When new dev starts using Docker layers, we red teams love infecting the layers. Oh, well, you're so mean already. I haven't even finished. One vector is publishing malicious copies of Docker images. That's so mean. Why would you see security folks? You just we're just learning. We're learning, and you're gonna go ahead and infect all of our stuff. It's kind of funny actually. But I mean, I'm assuming you work at a security company because that sounds pretty hardcore actually. Oh yes, Docker Hub absolutely has a lot of malicious images. So I actually really like that you said that, regex generator. So the reason why Dockerfiles are so important, you might say, hey, I see all these images that I can just grab. Generally, you don't want to use those. Generally, you're working for a company, like you should be building your own images. You can use their Dockerfiles as reference if you need, but you should be building them yourself. You should understand what's happening with them. Unless I only use these containers for things that I'm just doing off to the side. Anything I'm serious about, I will completely build my own image for it. All right, let's see. How would you force it to run like the apt-get? Yes, upgrade again instead of using the cache version. That is a great question. There are a number of ways to handle that. There's the easiest way is to do a build. So like if I rebuild this, nothing's going to happen. If I just try to rebuild that JavaScript container, nothing happens because there's been no changes. But if I wanted to rebuild it, with everything, you do a --no-cache, and this will skip the caching and it will rebuild everything from scratch. So that is how you would force a rebuild. --no-cache. Oh, Eric, you already threw it in there. Thank you. That's how you would do that. But there are a number of other ways. People have done some interesting things to make that stuff happen. There's a lot of people for a lot of package. For this, it may be a little bit different for like general system patches and updates, but some people just generate checksums and check against compare to determine if you need to do it to update it or not. That's a common paradigm, especially in the JavaScript world, so that you know if there's a change with that hash. You can do a little bit of magic against that, but yeah, no cache is an easy way to kind of get that going. Study sessions about mental models. Whew. Oh, hey, you are I need to come to a study session because I don't know anything about mental models. I don't even know what you're talking about, so I need to come to one of your study sessions. I don't mess with data scientists now. Yeah, data science, it's different world, definitely a different world. Can you explain multi-stage builds? Yes, I can explain multi-stage builds in a second. Hold on. Saving your dependencies isn't the worst thing ever, in my opinion. What do you think? I think it depends on, I just think it depends on what you have. It is not the worst thing in the world. Some of the reasons why it's not the worst thing in the world is, one, systems and mirrors go down. Someone's systems going down can destroy your entire build process. A single package that you need as a dependency, the mirror for that thing going down for temporarily, the servers that those things exist on going down, can break your entire build. And that can be problematic for a lot of people who are building things, over and over again. And so that's one problem. Other problems is unintended updates. If you're not, locked into the same version, there's a number of reasons why you may want to save your dependencies, but build time, it could be, I don't know. I prefer my container to be if possible, to be as self-contained as possible. I actually like to pass in locally the least amount of things possible, but that's just my preference. There are certainly trade-offs with that. Certainly trade-offs. Like ideally, I would like to be able to not give you any files and simply give you a Docker file, just the file itself, just the Docker file, and you be able to build this application. I know people who hate that. I like that. Like cloning the repo in the Docker file, rather than passing in the code. But I think it depends on what you're doing. I don't do that for my work stuff. I only do that for my stuff. I think it just feels more clean. but I do not know. So that's a great question about multi-stage Dockerfiles. Now, these are very interesting. And they can be used for a number of things. It's kind of a way for you to build an image, do some work, and then like reuse the thing that you built as the base image for what you're trying to do. And it's very interesting. It's a very interesting concept. I have not yet run into a situation where I needed to use Docker multi-stage builds. Yes, I have not run into a situation where I need to use them. I honestly, maybe I don't even truly understand them because I don't yet understand their true value or the use case in which you would use them. One of the challenging things about Docker ability to just keep the image size down, that makes sense. Such builds are useful for anyone who has struggled to optimize Docker files while keeping them easy to read and maintain. See, that's just like everything I come across about multi-stage Docker builds is I've gone through tutorials for it. I don't understand. I don't yet understand because they all tell me things like this. Struggle to optimize Docker files. I mean, what is? I don't even know. Like, what does that mean? That's very vague. Let's see. Multi-stage Docker builds are great for builders. Build time dependencies versus run time dependencies. Okay. So tools. Okay, tools and things you need versus the configuration things at runtime. That I don't know. I think this is one of those things where I need to experience the situation or just someone to put me in the situation to where this makes sense. You create one image that has all the build time dependencies, libraries, and everything, and produces the compiled binary. You copy that into the runtime container. Yeah, I have seen this as well. I think you can use these multi-stage things to lower the attack surface. For some of the things, you can copy that runtime into the container. Okay, that makes sense. I guess this only works for, yes, I guess I was about to say the example they're using is in fact a Go build, which makes perfect sense. Build the binary, and then build that into another container to be executed. Interesting. Yeah, I don't know. I guess I don't have that much of an opinion about it, I guess, because again, like I said, I've never found a reason to really use it. I think it's a very interesting concept though. It makes sense. It does make sense. Brian, is that Brian L. Robinson? Welcome to the channel. Thank you so much. You're Raider number 2 of the evening. Shout out to Brian L. Robinson. Thank you so much for the raid. Hello everybody from Brian L. Robinson's channel. Hope you had a great stream. Hope you were doing some pretty cool stuff. We are talking about Docker. We are doing a 3-week series called Contained about Docker. We're learning how to use Docker. We're learning how to build Docker images. We're learning how to run Docker containers. We're trying to figure out right now what multi-stage Docker builds are good for. Yeah. But is compiling your code not identical to the minimal purpose of containerization? Yeah, see, I mean, I guess that is what I don't understand the true nature, but if you're doing the compilation on the host and copying it into the container, then your local machine is a special snowflake. So now someone else can't reproduce the same build on their machine without knowing how your machine is set up and configured. That makes sense. That statement in itself makes sense. Maybe I don't know enough about security to know why that matters that much. Actually, I do know why that matters that much. That makes sense. That is the Eric.dev. That's the best. That's the most compelling answer I've heard so far, or understanding now that I have about it. That makes sense. That makes a lot of sense. Keep the image size down. That also makes sense because you're building out the executable. So this is so this can't always be, this is not like, this can only be used Can multi-stage builds only be used if your application code build delivers an executable? And I think that's my main question, and maybe that'll answer a lot of this for me. Maybe that's the biggest reason why I didn't understand. Does your app build, does the first stage or one of the previous stages have to eventually deliver an executable file, right, or an executable? If so, then I think that now this makes sense to me. If not, then I'm even more confused than I was before. It makes sense for image sizes for sure. Oh, online meetup tonight, 10 minutes. Blow a circuit. Oh, that's pretty dope. That is pretty dope. Had lighting blow a circuit. Hey, you know, wild things happen. That sounds pretty cool. That's awesome. I'll definitely come and check your channel. I'm gonna send you I've sent you a friend request now. Again, I like to, everyone who comes to the channel and supports and brings your community over. I'd like to share our communities. You know, science and tech is a great place to be. And I also like to check you out. So cool. Thank you. Well, it could be JavaScript. You wouldn't need npm webpack instead of the final image. Most of the stuff is just done sort of build automatic, but like, all right, I'm gonna look deeper into that because I do want to understand. I just don't see. I do see the benefit for image size. I absolutely see the benefit for image size. That makes sense to me. And also for things that are building to a target, people wouldn't know what kind of machine you're building it on, or like your machine configuration. I guess that makes sense. Something I got to dive into, something I just haven't needed to touch yet, or maybe it's something that I should have touched, but I didn't find that value there, so maybe I need to look deeper into there. But that's about as much as I know about that. But yeah, head over to this Docker Docs thing for references on that link that I gave you in Notion, for references on what you can use. Again, this Dockerizing applications takes a lot of finesse. Like it takes some understanding. It gets pretty easy, but you have to start to understand the paradigm of Docker and images as well. You have to know how to extract proper configuration. You have to understand what the heck things are doing. You got to understand all the dependencies as well. And so it can be tough. It is not super easy to jump in and start building Dockerfiles, but what is super easy for you to do, if you got a little bit of Linux foo, I highly suggest you head over to hub.docker.com. Take an application that you know how to install. We're always going to go back to Apache or Nginx only because they are relatively simple to deal with. And what you should do is you should take a look at their Docker file. So on the an image page, you can simply click these tags here, and it will link you to the public Docker file. And now some of these are grand, like this is intense, actually more intense than a lot of them. If you head over to like the Ubuntu one, it's pretty small, but it may help you start to see what's happening here, and you can start to follow things backwards. The way that you can follow things backwards is the Ubuntu one, not that long, but it's also going from this container called Scratch. And the Ubuntu container doesn't really do much but give you some tools and things. They've got some notes in here about what it's doing, so you can kind of check some of that stuff out as well. But I found for me that looking through Docker files helped a lot, helped a whole lot. And so I thought we were gonna have time to build something real simple. We could build something super simple really quick. We can do something like this. Let's do something really simple while we have time. Let me get out of here. I'm gonna make a new directory here, and we'll make our own little let's make one how hello world worked really quick. And so I'm gonna make a directory called hello world, gonna go into this folder and I'm gonna make a script really quick. So I'm gonna vim a script called hello world and call it hello world.sh. I'm gonna write a quick bash script here. All it's gonna do is it's gonna echo out, hey, we did some Docker stuff. Okay, we got this quick bash script here. Let's run it here really quick. So /, and it runs and says, hey, we did some Docker stuff. You can stick this into a container. So let's make a Docker file, which is gonna run all this Docker file. All this image is gonna do is run this script. So we're gonna vim a Docker file right here. And what do we call vim Docker file? And we're gonna do from, I'll do Ubuntu. All right, and we need, this script is here. And there's a number of ways we could actually get the script in here, but I'm gonna simply copy this from right here. So I'm gonna copy in hello world.sh. I'm gonna copy it into the container at tilde. Actually, no, let's do workdir. Let's use as many things as we can. Workdir, you all said it'll actually create a folder for me. So I'm gonna do folder script. So I'm gonna create a scripts folder here, and I'm gonna copy this to /script/ oh no, I don't even need to do that. I just need to copy it to right here because I made this the work directory. And so I'm gonna copy this from this file from the local machine to this location. So dot should work just fine. And then just to make sure it's good to go, I'm gonna do a run command, and I'm gonna chmod +x hello world.sh. And so what this is gonna do is gonna ensure that this script is executable. It's gonna give it the permissions. You haven't learned permissions yet. You're about to learn about, if you're interested in Waddle, you're about to learn about permissions, I think maybe tomorrow. So you'll learn about what that is. And then I'm gonna add a CMD, which is just gonna run this. And I think I can do, the workdir is already here. I think I can simply do, I think I can hit it with a /. I don't know. I may just be able to call the file itself. Let's see. This might be the equivalent. Let's try this on for size. Let's try that on for size. I don't even think I need. Let's try that on for size. And I'm gonna do Docker build hello world Docker build -t hello world and build right here. And it's gonna run through the things for me. So 5 steps. Step 1, from Ubuntu. Step 2, set the working directory, and it's gonna, it's creating a new layer here, removing the intermediate container. And now it's step 3, copies it in, it goes through. So now if I try to do Docker run hello world, what did I call it? I called it just hello world. So first, let me make sure it built Docker images. It looks good. If I take a look, we have this hello world thing that was built 29 seconds ago. It is 73.9 megabytes. That's very big for what we're doing with it. It's that large because we're using the entire Ubuntu container. And if I try Docker run, I do a Docker run, hello world. It says, all right, hello world sh not found. So we can do a couple of different things. I can call it from the full path, which may make sense. So let's rebuild this. Let's vim our Docker file here. Let's try calling the full file. So let's do /script. So maybe it's not called hello world sh. Is that what I called it? I need to build it again. So if you make a change to the Docker file, whenever you make a change to the Docker file, you must then rebuild. And so when I rebuild, it does it again. And so notice this, it says from Ubuntu, Then when it gets to this one, it says, hey, I'm going to use the cache here and copy. It said to use cache. Oh, so I need to build it with no cache because it didn't see a change, because I made the change to the file and not the Docker file. All right, so let's run that again. And hello world not found. Now, this is exciting. I know what the problem is. I want to show you how to figure out what's happening. So this is running, it's not really working, and I'm like, ah man, you know, this should be working. You know, I'm copying the thing in, I want this to work, and I say, hey, I want to know what's right here. And so you can do you know, your command to make it run full time, and you can log in and see what's happening on the server. So itd hello world and /bin/bash and docker ps and docker exec -it 222 /bin /bash. All right, and so it puts me in the script container, and look at this file is right here. And I do a pwd, this file is right here. It is right here. And the reason this isn't working is because look at this is actually incorrect. It actually doesn't like the tilde when you use the tilde inside of the bash script. So what it ended up doing was creating a tilde directory underneath the root. So like if I do ll/, I created this tilde directory. So I actually am executing the wrong directory. So you can do a couple different things to fix that. I can say, all right, I'm tripping, that was a mistake. Where I really wanted to go is, let me go cd pwd. What I really wanted to go to is /root. So I'll say, all right, this is the right directory that I want to do. Let me go ahead and try that one out. So let's log back out. Let's modify our Docker file, and let's copy work there /root. Oh no. It's /root/script. And I think this one will work better. I think this will fix it. It'll give it the right location, I hope. And I'll build it again, and I'll run it. And look at that, it runs the script. Hey, we did some Docker stuff. A simple concept here. I use that to run a bash script. You don't really need to do all that to run a bash script, but we did use it to run a bash script. We were able to build out a Docker file that did a couple different things. It set a work directory, it copied our file from our local computer into the container, and then we set the command that was going to run when the container started. So when the container was called, it ran this thing and it spit that out to the console. And if I do a docker ps, only one container is still running. This is the old one that I started up a while ago, because like I said, when a container is done doing its job, it goes away. And so that container did in fact go away. And so if I do a docker ps-a, I can see that there's going to be one. There's gonna be a few that ran using the root script that was run 53 seconds ago that exited because it actually did exactly what it was supposed to do. The idea, there is a CI/CD server, has to be provisioned and set up with the right build dependencies. Multi-stage Dockerfiles allows any machine with a container runtime to be a build environment. Difficulty with the build servers can be also a dependency issue with multiple apps. Okay, idea CI/CD provisioned right build dependencies. That makes sense. That does make sense. It makes sense to me. My question after that would be, why wouldn't you just use circle or something else? But no, I'm joking. I'm messing around. That makes sense. I'm just trying to apply. I'm actually trying to retrofit and apply this to things that I've done, to just pull out things to see if it worked. I like to apply when I'm learning a new concept. I like to try to apply to things that I've already seen, or use what I've already seen to mentally create a scenario in my head, where this would make sense. I understand that, Eric. That these all help substantially. Everything, I think everything you guys have given me tonight is giving me a more complete picture on when I would use it, and why I would use it, and why people do use it. It makes sense. That makes sense. I don't see myself running into those problems anytime soon, but that's just because I'm probably not gonna be working on anything majorly big anytime soon. And it feels, multi-stage Docker files feel big. They feel like they're for a big thing. So I don't know. Let me know. All right, so we wrote a quick Docker file there on the fly to do that. So you could actually take this, and you actually don't need to do this. You can actually specify, like what I did here. You can actually specify that in the copy as well, like the permissions. But you could actually take this exact Docker file and insert your own script. You could use it to do a lot of simple things that you've done before to kind of practice. You could remove everything and just run a couple commands and see what happens. Actually, one last thing I want to tell you is commonly when people are doing apt updates, apt update and apt upgrade, it's commonly the first thing you'll see when people are building new containers. This line will be in there somewhere. I'm gonna run this. And it's gonna run real quick. It's gonna go through, maybe. It shouldn't be stopping there. I'm seeing it. I don't know why this is doing this. I'll leave it there. That might be a large package. No, it goes past the 10 this time. But when you're doing these updates and upgrades, or any type of installation, that's going to require some user input, it's going to fail. It's going to fail. It says, hey, upgrade not found. It returned a non-zero exit code. These will fail every single time. And they will fail every single time because you have to, I actually don't think this needs a -y. The update needs a -y, but anything that does need to be accepted is you have to do a -y. And this is a Linux thing, not a Docker thing. But for anything that's going to need some type of input, if you need to say yes or no, a -y will submit a yes command for these things. So make sure you add that -y. There's no way to interact during this build process, so you have to work around those things with some type of configuration. Yeah, well, if that didn't fail for that reason, apt upgrade. So just be wary of that. The -y is pretty important. You might run it, you might run into that problem and not realize you are what's happening. You start to get an error. You might think that the update or upgrade is failing, and that's not the case. It is simply because you need to interact and say yes, you want to update or upgrade. So yeah, so just be aware of that. The -y will allow you to say yes. Have you used Alpine? Yes, I use Alpine for pretty much everything. Yep. Instead of Ubuntu, I'm only using Ubuntu because it's a commonly known distribution for right now. The thing that we will be building on the last day will in fact be using Alpine, but yes, it's specifically for size. 100% is SUID sudo. Sure, exactly. So yeah, so we'll be writing Docker files literally every day for the rest of this. So the other time this week and the last 2 days, the last day, so the end of the second to last day, so the end of Monday of next week, I'll be introducing you all to an application that you're not familiar with. I'll be running through the architecture of it and how it's built with you, and we're gonna do that beforehand. We're gonna do that on Monday, and you're gonna get to look at it on Monday, so that when we hit Wednesday or Thursday, when we hit Thursday of that week, or we're gonna look at it Tuesday, so when we hit Thursday of that week, the last session is going to be breaking down an existing application and understanding how to Dockerize that application. And so we'll be writing probably a few Docker files that night, and so we'll get we'll get tons of practice that night, but we'll be writing Docker files every night until the end, so you'll get much more practice with this. So if it's overwhelming right now, don't sweat it, not a big deal. You'll get all the little tidbits as we kind of go farther and farther. Yeah, Alpine it's pretty much almost de facto. Pretty much every image you find will have an Alpine version along with it that you can grab. I mean, Ubuntu probably won't because that makes sense. But yeah, any other tool that you use will probably have some type of Alpine tagged version. Yep, see, so like the main one, the latest is not built on that. It's actually built on Debian, but they have a whole line of Alpine tagged images as well that are built from Alpine for sizing purposes. Alpine, it really is pretty de facto. Alpine it really is almost de facto microservice though. Or Docker base has to be CentOS or Red Hat due to security concerns. Joey Bites, yes, that is very interesting. It's very interesting. I think when that happens, it makes sense. Remember, these distributions are just a list of, packaged up applications and tools. But yeah, that happens places as well. That's very interesting, actually. Yeah, it does make sense. I mean, people do that with golden images all the time for VMs. Seems a little bit weird for containers, but it's all good. Just showing, will part 3 be available to rewatch somewhere? Mrs. Smoothie, yes. This will stay on here for 14 days. I have not put the other ones on YouTube yet, but they will all be going up on YouTube. I'll try to export them and do them tonight, but they will remain here on Twitch for 14 days if you want to watch them there, but they will be up on YouTube as well. After doing this, you should continue with Kubernetes. Yes, so Kubernetes, that might make sense. So after this, I kind of announced it. It's going to come out this week, but it's going to be Git. I think I announced it yesterday but the next sessions we're going to be Git and Terraform. If anyone's interested in those things, we will be doing a Kubernetes one. The problem is that one was bigger, and that not in teaching Kubernetes, but more so in making Kubernetes make sense by actually deploying figuring out a genuine application that has multiple pieces to put together to kind of really make sense there. So that will be Kubernetes will for sure be coming. I need to finish my Kubernetes the hard way stuff, but yeah. The conversation, good info. I learned a lot here. Use Docker a lot, but never really spent time learning. Awesome. I appreciate. Harold. I ditto. Great conversation. I thank you so much for coming through, bringing some energy, having some conversations. I learned a lot from you all tonight. Hopefully, this is making Docker feel a little bit less crazy. But like I said, I think Docker is one of those things that the more you play with it, the better you'll get. And I also think your ability to be great at Docker heavily depends on your Linux skills as well, because it really is just Linux. It's the technology is cool and all, but it's really just Linux. So that's why I'm running both of these together, to be honest. I'm running the Linux portion and the Docker portion together because I think that they play on each other pretty well. But yeah, Git and Terraform will be next. But that's it. That is it for this evening. Tangible takeaways. I hope you learned that image management is pretty simple. You can pull images down using the pull command, that you can push them up if you log in first. You can tag images with new names from other images using the tag command. You can remove images, but you can only remove images when all of the containers that reference them are first removed. And we learned how to do that container management last time. And that we learned that, hey, Dockerfiles are just a set of instructions to build an image, and we learned some of those main instructions, the froms, the adds, the CMD, the entry points. I would dive into those a little bit more. You don't need to become it'll take a while for you to become an expert on all these things and really understand. I reference this literally all the time. I never remember the right syntax, but understand at least what you can do, and start to try to build some things, I would start to look at some of these Dockerfiles, not start to build some things. We'll start to build some stuff together on here, because again, it's not super easy to just go build something in Docker. But again, if you know how to, maybe try doing what I did tonight though. If you know how to write a little script, try to write a script and see if you can get a script. Maybe you know how to script in JavaScript or Ruby or something. Maybe you want to try to get those to run in a Docker container instead. But I don't know, have a little fun with it if you can, or just take a look around at other people's Docker files and notice that yes, a lot's happening here. This is not Docker stuff. This is all just Linux stuff. So if it's very confusing to you, it's because you're not comfortable with Linux rather than not being comfortable with Docker. So don't let that set you back. Just know where you need to focus. And when you're searching for things, don't be searching like Docker and curl. Like, no, these are all Linux commands and this is just doing Linux stuff. But that's it. So we use Waddle to set up contained and right with Terraform, and put them in Kubernetes. Sure, that I like that flow, makes a little bit of sense. I do like it. I use that dev container for VS Code that points to a Docker file to use for remote container environment. I don't know what .dev container is, but I would like to know. That sounds pretty cool. Oh, this is fancy. See, I see VS Code. I'm always impressed by VS Code and the things that you can do. VS Code remote server was phenomenal when it first came out. It's pretty dope. I'll check this out. I might convert to VS Code with Vim key bindings. I really might. We'll see though. We'll see. If not only to do some, I'll use it in tandem to do some remote development with other people because of